Classification of linear homogeneous partial differential equations of the second order. A linear homogeneous partial differential equation of the second order is of the form A partial square u partial x square plus 2h partial square u partial x partial y plus b partial square u partial y square plus 2f partial u partial x plus 2g partial u partial y plus e u equals 0, where a, h, b, f, g, and e may be constant or functions of x and y. We note that equation 1 looks like the general equation of conic section, which takes the form a x square plus 2h xy plus b y square plus 2fx plus 2gy plus e equals 0. This equation represents elliptic if ab minus h square more than 0, parabolic if ab minus h square equals 0, hyperbolic if ab minus h square less than 0. Laplace's equation in two variables is of elliptic type. The Laplace's equation in two variables is of the form partial square u per partial x square plus partial square u per partial y square equals 0. Here a equals 1, which is the coefficient of partial square u partial x square, h equals 0, which is the coefficient of partial square u per partial x partial y, b equals 1, which is the coefficient of partial square u partial y square, f equals g equal e equals 0, which are the coefficient of partial u partial x, partial u partial y, and u. So ah minus ap. So ab minus h square equals 1, which is more than 0, and the Laplace's equation in two variables is of elliptic type. The wave equation in two variables is of hyperbolic type. The wave equation in two variables takes the form partial square u per partial x square minus 1 over c square partial square u partial y square equals 0. Here a equals 1, which is the coefficient of partial square u partial x square, h equals 0, which is the coefficient of partial square u partial x partial y, b equals minus 1 over c square, which is the coefficient of partial square u partial y square. This is b. F equals g equals e equals 0, which are the coefficient of partial u partial x, partial u partial y, and u. So ab minus h square equals minus 1 over c square, which is less than 0, and the wave equation in two variables is of hyperbolic type. The heat conduction equation is of parabolic type. The heat conduction equation takes the form partial square u partial x square minus 1 over k partial u per partial t equals 0. Here a equals 1, a the coefficient of partial square u partial x square, h equals 0, the coefficient of partial square u partial x partial t, b equals 0, the coefficient of partial square u partial t square, f equals e equals 0, which are the coefficient of partial u per partial x and u. Finally g equals minus 1 over k, g the coefficient of partial u per partial t. And so ab minus h square equals 0, and The heat conduction equation is of parabolic type. Thank you for watching.